Hey, welcome to another tutorial where we will be tackling this popping rocks setup. It's a very basic setup, but it covers some cool little techniques and tips with RBDs. So let's dive in and check it out. I'm using Houdini 19.5.303, but I think this will work in any Houdini version that's fairly recent. Let's start and we'll create a geo container, and I'm going to just call this rocks working. If you've watched any of my tutorials, you know this will be yellow, and I like to do my working in some containers and then send out my geometry to render in others. The first thing I want to do is I want to just grab some rocks. I'm just going to paste a file here, and I created some rocks in a Patreon tutorial. So if you're interested in that, you can head on over to Patreon and take a look. But I now just have some rocks, and each frame I have a different rock. Now the thing is that I want all these rocks to be on a single frame so that I can instance them on some points, or I can copy them onto some points. And there are some fun ways that we can do that. What I'm going to do is just drop down a time shift, and I want to just make sure that I clamp to both, and I just delete this channel and I set this to 15. So now I'm not going over 15. 15 will lock it into place. And the next thing I want to do is just pack this geometry. So each frame, this is a packed point, and I can then run a trail. And this trail node is going to kind of be the ticket. I'm going to preserve the original, and I'm going to do a trail length of 15. And this doesn't seem to have changed much, but you can see as I keep going forward, it's keeping the previous iterations and it's piling them on top. So now if I do a time shift and I delete this channel, but I set this to 15, now we have 15 rocks, and you can see I have 15 points and 15 rocks all stacked on top of each other in one big pile, which is what I want, because now I can easily copy these onto several points. But of course, in order to do that, I need a variant attribute. And so I'm going to use this enumerate sop, set it to points, and just create a variant. The last thing I'm going to do is I just want to transform these and just make them a little bit smaller. All right, so now I have some rocks that I can do something with. So let's create some points to do that. And to create points, I like to use an attribute randomize. This is has this neat visualizes points, and now we have a block of points, but I wanted it as a sphere. So I can just set this to inside sphere. And again, let's just turn this to be a lot smaller. And we need a lot less points, maybe something like 25. And we can use a copy 2 points. And now we have some rocks on here. And of course, we need an attribute adjust integer. You can use an attribute from pieces, or attribute from pieces. Yep, I like to use this one. It's a bit easier for me. Just set this here, and I know I have 15 pieces, so 0 to 14. And in here, if I check this and set this as variant, I now have a random rock per point, which is awesome. That's what I want. Now, the next thing I want to do is use a mops randomize. You can use an attribute randomize if you like, but this has everything in one, so I just find it super fun and fast. And I'm also going to change the scale. And I have some that are really small, which of course I don't want that. I want them to be quite big. So in fact, we can make these really big, something maybe like that. Looks good. And we have lots of overlap and intersections, and that's okay. We need a lot less points, maybe just 11 for now. So we are on our way. What we can do now is just drop down an assemble node. This just creates some packed fragments. So before, well, actually, I think they were already packed, but now they were packed geos. Now they packed fragments. And if we add a RBD bullet solver, let's go back to frame 1. Let's just remove gravity. And if we hit play now, nothing happens because we have no forces, we have nothing happening. But what we do want to do is we want to de-intersect these. We want these to no longer be intersecting. And we can use this super handy function that I found on the CG Wiki called found overlap. And this is just if you say I had found overlap equals 1. And now we hit play. You can see that on frame 2, it de-intersects these as best as it can. And it kind of gives them this velocity to shoot these rocks outwards. So that's pretty cool. Now we have these rocks going outwards. I'm not sure why these ones have such curly noise. Let's see if we can figure out what rock that is. There we go. Okay, so we won't use that last rock. It looked a bit funky. But now we have these rocks and they shooting outwards really nicely. So the next thing we want to do now is we need to create some sort of an emission. And so if we have a look inside RBD Bullet Solver, you can see we have this emit. And if we hit play, each frame it's going to emit. And so we obviously don't want that many emissions. So we need to set something up that's going to allow us to kind of create a slightly better emission. So let's do that over here. We're going to use a switch node, and we can use a null. And so if this is on 1, and let's just keyframe it. So we will set it like this, and on frame 2, we'll set it at 1. Now when we hit play, you can see it emits on frame 1, and then it doesn't emit anything else because there's no other geometry for it to emit because we've switched it off. But now if after frame 9, we switch this back over here, a few frames, and then let's switch it again. And we're not going to actually use this, but this is just to show you what this is doing. So it emits once, and then you can see it's emitting again, and then it stops emitting. So it adds in and then stops. Now, obviously, we don't want to do this. We're going to use a little expression, and this expression is going to allow us a lot of flexibility and freedom. So what we're going to do is we're going to use the frame, and we're going to use something called floor. And what we want to do now is we want a random number that's going to happen between maybe 3 and 9. So every 3 or 9 frames, I want you to emit. And so if these equal 1, now if we have a look at just the switch, you can see it's on 1, it's 0, 1, 0, and it's just randomly switching between these. And I actually want to switch these inputs around. And so now when we hit play, you can see that it's randomly emitting maybe 1 or 2 frames, and then it stops emitting. And that's great. So now we get something that's kind of doing a cool emission. And now to further break this up so that we get some really randomness, we can use some of these other point functions to get randomness. And one of them is the number of points that we're emitting from. We don't want this to be, again, just the same number every time. So we can use a fit01, and we can use random $f. And the reason I'm using fit01 is that the random function always gives a 0 to 1 attribute, and I want 4 or maybe let's say 9 points. So randomly it's going to emit 4 points or 9 points every frame. So you can see on frame 1 it's 8, and then it's 7, 5, 8, 9, 6. So every frame there's a different number of points. So you can see here it's doing that. I get some geometry glitching. All right, so that's cool. The other thing I can change is I can just change the variant, and here we can just say $f. So now we get a random variant every frame. And to even further change it up, I can just add $f into my rotation seed. So now I'm getting real random rotation. And because this is still not enough, we can add a transform, and we can just set a $f over here. So now it's randomly rotating as well as all these other things are happening. And this just keeps adding some nice details and variation to really break up the source that we're feeding into our RBD solver. So the next thing I wanted to do was, as I have a look at this now, you get all these shapes that are kind of floating around, but I want to keep them towards the center. And so I'm going to jump inside, and I'm going to use a pop attract. I'm going to give this a nice strong value of 10. And now as these pop out, you can see that they're trying to maintain this inward shape. So they're trying to pull themselves back into the center. So you get this cool shape. But something that I realized is as this pops more and more in, these have nowhere to go. And so they kind of like get stuck there. So I wanted, once they popped, I wanted them to really force themselves outwards. And so I created a little velocity here on the surface that I could feed into the solver. Let's create a point velocity. And for this one, we can just add a nice big curl noise. If we have a look at this, I think we need to use an add node Let's just delete geometry but keep the points, and we can now visualize our velocity. So now we have these really nice, like strong velocities just shooting out, and it'll just break up the noise a little bit and push these outwards. So you can see now we get a lot more kind of like random motion, and these are kind of pushing themselves out. And of course we can increase this even more if we wanted to really push them out, and they'll keep trying to come back into the center because of the pop attract. So I'll just pull this down a little bit. So this is looking pretty good. The next thing I wanted to do was I wanted to randomly delete some of these points or some of these pieces as the time went on. So the way that I did that was with an attribute or with a geoangle. We're going to delete pieces. All right, so we randomly have these pieces that are popping in and then moving towards the center. And over time, we want to just pick a few pieces, delete them, and then as more are spawned in, more are deleted, and we kind of get this constant turnover of in and out, in and out. All right, so let's talk about how we can delete these pieces. So we're going to create a float called age new, and we want to fit this to 0 to 1, and this is going to be a random number based on our current frame. So we can just set this 0 and 1 for now. So some random number between 0 and 1, and we can change this if we need to. The next thing we want to do is we want to create a live threshold. So this is just going to be a simple channel ramp, and this is going to be the control for what points are deleted, and this is just going to be based on a random point number, something like that. And then to control it all, we're going to say if at age new, which is the first thing that we created, some random number between 0 and 1 is bigger than or equal to our alive threshold. Make sure that I spell this the same and all, even if it's spelled wrong. Then what I want to do is I want to remove point. Remove point 0 at ptnum. So basically, if this one is bigger than this one, then delete some points. And so we can create a slider, and I know from building this already that I need a very, very small little dent in here for this to work. Something just like that I think will be enough. So let's hit play and see what we get. So it starts to pop in, and you can see some are being deleted. There, some here are deleted and some there are deleted. And at this point, maybe not enough are being deleted, because you can see there's more and more are being emitted and not that many are being deleted. We need to kind of keep it at a constant delete emit ratio. And so now we have this setup where we can just kind of come in here and pull this further down. So more are now deleted. And you will see that if you go too crazy with that, these get deleted too fast and you eventually end up with only a few. You can see here now they're getting deleted really quickly and maybe too quickly, depending on what you want. And of course, you can change the random seed that's happening inside if it's not deleting the way that you want it to delete. And I think now we could even delete faster still. If we pull these out like this, you'll see now this goes really quickly and it deletes them super fast. So now it's just a matter of iterating and trying different values. And one of the great things with RBD is it's really fast to iterate. As you can see, this is near real time. I'm just playing through. I'm not speeding anything up. And this is actually pretty cool. Maybe the pop attract needs to be a little bit stronger, but you're getting some cool popping in and out. The next thing I wanted to do was just to have some nice overall axis force. So we can just add a nice big axis force in here. And make it a little bit bigger and longer. Something like that, so that as they come in, they don't fall out of this. And now you can see that this will just slowly spin around and spin these around, which gives it a bit more of a kind of a nice natural motion as these pop into place and all over the place. So that's the base of the setup. There really isn't too much fanciness going on. You emit some points, and then inside the solver you delete some points, and because it's inside the solver, you're not doing it post simulation, the other pieces kind of fall into place and they fill in the gaps, which is really cool, and it gives this really fun effect. So I hope you enjoyed that. Nice little simple setup. If you want the scene file, I'm going to drop it on my Patreon. You can take a look at it there. Otherwise, I'll see you next time for another short, quick, fun tutorial.